let's look at what happens if you weigh yourself on a scale. So, weighing yourself on a scale. And you will see later why I put weighing yourself, the word weighing, into quotes. So, let's picture the situation. We put a scale on the floor and you are standing on the scale. Now next let's look at the forces which are acting. What do we have? We have the scale is acting on your feet, and we will call this the normal force that the scale is acting on you. Newton's third law tells us that you exert on the scale a normal force, u on scale, which is in the opposite direction, but then the same magnitude as the normal force that the scale exerts on you. The other force which is acting on you is the gravitational force, that is the Earth acting on you, which we also call your weight. And of course, because Newton's third law, you exert a force on the Earth which is opposite in direction but equal in magnitude to the force that the Earth exerts on you. Now, the one thing which is important to understand is that what the scale reads is proportional to the normal force that you exert on the scale. So the scale reads the normal force that you exert on the scale. We know in magnitude, note that I leave the arrows off, so I'm talking about the magnitudes. This is the same as the normal force that the scale exerts on you. The directions are opposite. Let's just call this for simplicity n. So I will use n for the normal force that the scale exerts on you, which is in magnitude the same also that the normal force that you exert on the scale. That is the scale reading. So if we want to learn what the scale is actually reading, we need to find the normal force that the scale is exerting on you. Let's draw a free body diagram for you. So the free body diagram for you. First, I define a coordinate system. I will define positive y up. Direction of x really doesn't matter because there are no forces in the x direction. Your mass goes on the center of this coordinate system, and then what I will do is I will draw in the forces. What we have acting downwards on you is your weight, and on the surface of the Earth that equals to mg. And upward, on acting on your feet, we have the normal force. Newton's second law then if I sum up over all the y components of the forces, I get your mass times the y component of your acceleration. Because you are at rest on the scale, this y component of the acceleration is 0. So what you then get is, we get the y component of the normal force plus the y component of the weight is, because the acceleration is 0, 0. The y component of the normal force is in the positive direction, the magnitude of the normal force, in the negative direction, the magnitude of the weight, and that equals 0. So from that it follows the normal force is equal to your weight, and we know your weight is mg. So what that means is, if the scale is at rest, the reading is your weight. This will not be true if the scale is actually, and you with the scale, if you both are accelerating, and we will cover this in another screencast.